All right, in the final example here from this lesson, we're going to find the volume of the solid generated by revolving the region bounded by the curve y equals x squared, the y-axis, and the lines y equals 1 and y equals 4 around the y-axis. So we'll draw a quick little sketch. Got y equals x squared. Oops. And we've got the y-axis. And the lines y equals 1 and y equals 4. And so we're taking this region in here. And we're revolving this around the y-axis. So we want our slice to be perpendicular to the y-axis. And so now we're looking at this slice, and since it's perpendicular to the y-axis, when we take this slice, we want the distance to be some value based off of its x-coordinate. So the first thing we want to do is go ahead and solve the equation y equals x squared and solve it for x. We get x equals plus or minus square root of y. Now that breaks down into two parts. We've got the right branch of the parabola, this branch over here, which is x equals positive square root of y, and then we have the other branch on the other side of the vertex, and that's the branch x equals the opposite of the square root of y. So for our integral, we're going to use x equals the square root of y as our radius. If we look at a typical slice, we now have the distance being from right here, which is x equals 0, over to the curve, which is x equals the square root of y. And so this distance, the radius of our cylinder, is going to be the square root of y. Now we'll set up our integral. Since we're revolving around the y-axis, everything in the integral should be in terms of y. So we've got our pi out in front. Our limits of integration are from 1 to 4. Our radius is the square root of y, and our thickness of our cylinder is dy. And so this just turns into pi times the integral from 1 to 4 of y dy. I have a choice here if I want to integrate by hand or go ahead and use my numerical integral. I'm going to go ahead and do this by hand. And so we evaluate that, and we end up with 8 pi minus pi over 2, or 15 pi over 2. I'm going to go ahead and double check, break out my calculator, and do the numerical integral. And so I've got pi times numerical integral of, and I can use x instead of y in there, and my limits of integration are from 1 to 4. Go ahead and punch that up. And I'll double check, compare that to my answer I got by hand. And they match. And so I'm happy. And there's your volume of your solid. And that's the end of the lesson.